All right, so this is problem number 1 on practice test 2. So the question is, a block is pushed across a rough horizontal surface from point A to point B by a force, magnitude P equals 5.4 newtons, which is drawn here. The magnitude of the force of friction acting on the block between points A and B is 1.2 newtons, and points A and B are 0.5 meters apart. If the kinetic energies of the block at A and B are 4.0 joules and 5.6 joules respectively, how much work is done on the block by the force P between A and B? So first we're going to look at this drawing and we're going to start labeling some things. So we have the distance between point A and point B is 0.5 meters. We have this P force pushing the block, and that's 5.4 newtons, and we have a friction force of 1.2 newtons. And then we have kinetic energies of both at point A and point B. A is 4 joules, and B is 5.6 joules. And what we're looking for is how much work is done by the block by force P between A and B. So we're looking for work. So what we first want to do is look at the work put on the object externally. So to do this, we do work of the external equals the kinetic energy final minus the initial kinetic energy. So this is 5.6 joules minus 4 joules, which equals 1.6 joules, and this is the change in kinetic energy. Now with this problem, we're given friction, so we need to remember that that's going to add additional work. So what we're going to do is then find the work due to friction. So work is equal to the force of the friction times the change in the distance between points A and B. So we're given the force of friction as 1.2, and the distance of change between points A and point B is 0.5 meters. So the work due to friction is 0.6 joules. So the final step is to add the external work and the work of friction together to get your overall amount of work done between points A and B. So this is 1.6 joules plus 0.6 joules, which equals 2.2 joules. And that is your final answer.